Alright, so hello everyone and welcome back to another stream. Last time we left off with trying to widen the character classification or character identification in the 1 billion row challenge, and we didn't quite get to a result that was working. Today we are going to do a very short session where we're trying to fix it and maybe get it to work. So let's not waste any more time and try and get it going. Now, let's also, one more second. Alright, so let's get it going. So I'll open the chat. There we go. Let's go into, we are in the directory, 1brc. Let's go into our main C file and let's look at where we left off. So find character wide was the function we were implementing, and it didn't really do anything. It was slightly faster because we were throwing away a lot of the work we were doing, essentially calling this on the same bytes over and over again, which doesn't really provide any huge benefit. And yeah, so I want to change the logic here a little bit. So I want to remove the this end cursor business and also this cursor business. Yeah, or do we? I don't know. Okay, let's just say U64 chunk length is equal to the end cursor minus the cursor. Let's also say we have an offset of 0 at the very beginning. Let's put this here or so, I don't know. And in the index array, we want to store our offsets, and they're all positive. And I think it can only be this plus 1. Then we also have an array length. We have the new line register, the semicolon wide register, and then we do this while offset is less than the chunk length. Now length to end we don't care about. Offset, we set it up there. Array length is 2. Now, if the chunk length minus the offset is greater than or equal to the size of the wide register, we want to do the wide comparison. So we do a load, an unaligned load from our cursor with the current offset. This is correct. Then we do a compare against the semicolon, a compare against the new line. Then we do a move mask into a 32-bit register and another move mask into a 32-bit register. We OR the two masks together. We have to see, do we want to do this way or keep 2 arrays? I'm not sure about that. We get the match count and we get the trailing 0 count of the bit mask. So basically the index of the first bit set. Then we store this index with the current offset in the index array, and then we reset the lowest set bit with BLSR U32 on the bit mask. Then we increase the offset by the size of the register and do that. Now here I want to do something else, because here we know we are less than the size of the register. We can just do it simple. We can just do a simple scan. So while a simple scan to the end. And yeah, so for U32I0 I is less than chunk len minus offset and I++. I don't know if we want to do it this way. Then we want to do a comparison. So if the U32 index is equal to offset, or we can also do something like this. Or do we do it differently? Like, let's see. Okay, let's do it this way. Offset plus I. So if cursor at index is equal to the new line, or the cursor at the index is equal to the semicolon, we say index array length plus plus is equal to the current index. Then we do the scan, and finally we set, or we could also do this a little bit differently. So while the offset is less than chunk length, then we do it offset, offset, and offset. So this way it will consume the entire thing. Now, we need to keep track of the line start. So let's say here U64 line start is equal to 0. Then we remove this advance here, and new line index is this. And here we set line start to new line index plus 1. And we don't increase this. We don't increase the cursor. And this may or may not work. I'm not sure. Build, advance, new line, or line start. Chunk length. Oh, I++. It should be offset plus plus. Okay, it builds. Let's see. In the build, we should use the debug build. Yes, we did. So let's move through it again. Let's use this breakpoint here, and let's start debugging. Right, so we can see again the semicolon reg. We can we print this as a string? Now we see that it is a bunch of can we print this as hex? Yeah. So this is 0x3b, 0x3b. Now 0x3b is the semicolon. This makes a lot of sense. And the new line reg as hex 0a. So char 0x0a is the new line. Okay, so that seems to be correct. Oh no. So it is questionable whether we want this to be all in one array or whether we want two arrays here. Yeah, let's just see. So this is true. Let's go. We have the 2-bit masks. So let's look at the current cursor plus offset. Offset is 0, of course. Let's set something up here. Like, let's look at cursor plus offset. And yeah, that's good. Let's also look at the semicolon bit mask and look at it as binary. And also look at the new line bit mask as binary. Also look at the city stir and the temperature stir, which are not existing yet, but that's okay. And all right, so we have these bit masks here. So at index 6 we have a semicolon, then this should be the new line, and so on and so forth. So let's see, let's also look just at the index and at, or maybe let's look at cursor plus offset at the index. Yeah, so a semicolon, and maybe let's also look at the bit mask. So if we call bit mask and binary, if we call BLSR on this, it will unset the lowest set bit. Then the next index will give us a new line, a semicolon, a new line, and another semicolon, and then we are done. We increment the offset. So let's also get the offset in. It's 32 because the register is 32 bytes long. Then we do have at least 2 entries in here, which means we can parse some lines. Now let's get the semicolon index and the new line index and the city stir and the temp stir. So they appear to be correct. Let's also look at temp I16, which will now be 287, which matches this. All right, so let's move ahead. We can parse multiple of these. Let's look at the city stir. This is now, let's head -n10 measurements.text. Now measurements small.text. So the city, however you want to pronounce it, seems to be correct. And 29.2 for the temperature stir, which should now be in here. So that's right. Temperature is 292. Insert the record, and then we should have nothing left. So if the array is odd, the array length, we reset the array. So let's look at the index array. It has the value 31 at index 4. After that, it should have the value. Oh, so this is a bug, of course. So odd. This should not be in here. So yeah, let's just do it again. Fire up the debugger and continue. Go here, do the wide comparisons, do the extraction, go here, do the insert, and then reset the array. So index array at 1 is now 31, and the array length is equal to 1. Now, let's do this over and over and over again. Let's just see if it works. Now, we get a semicolon index, we get a new line index, we get a city stir. Let's also see whether the city length is correct. City length, it is 7. Vilnius, 1, 2, 3, 4, 5, 6, 7. So this appears to be correct. The temperature stir is 0.1, which also appears to be correct. Yeah, this is also the third one. And yeah, it does it multiple times. Then it goes here. Now it is not odd anymore. And we do the next comparison. So maybe this works. Let's just try and see what happens if we run this in debug. And let's remove result.csv and run it again. Result.csv Berlin, and it appears to be correct. So it seems like it is correct. So I now wonder, let's git add dot git commit. I wonder, profile scope. Let's add a profile scope in, yeah, where does this profile scope go to? Let's just say it just profiles this loop, like profile scope and find character wide. This profiles the scope, which just does the comparison. Let's build it again. Okay, so now we see find character wide. It takes 216 milliseconds. Yeah. yeah, what was the previous value in this? Git log one line. White character matching. Let's go back to this one. Git checkout this. Oh no, git status, git add dot, git commit, white character identification with index extraction. Dang it, white character identification with index extraction. And now do the checkout and then build again. Now, is this the build with O3 is the question. Yes, it is the build with O3. And is it with small? Oh, we don't have the measurements. Oh, it does it with measurements small. Let's also see what the lane count is. Lane count is, let's just set it to 1. Let's build it. Let's run it. And we don't get any information because it also doesn't include shit. -d prof enable -d obrc debug. Build it again. Okay, so find character took us 208 milliseconds in O3. All right. So let's check out our previous one, which was master. Oh no. Git restore dot git checkout master. So 208 milliseconds is the time we need to beat. Now this is with debug enabled. Let's do O3. No, let's do the O3. We should implement a flag for this. Now we can see that find character wide significantly improves the performance of our program. We're now at 56 milliseconds instead of 208. So I like where this is going. But this of course has the cost that our code is now a little bit clanky. What are you building? I am building a solution for the 1 billion row challenge, which is basically parsing this measurements.txt file, which head-n10, which is basically a city name, a temperature with this fixed point in this fixed point format. And then we're trying to report the min, mean, and max for each of the cities. Now, one thing I also haven't implemented yet is the following. I have seen how do we get up 1BRC? How do the results have to be? Oh yeah, the task is to write a program which reads the file, calculates the min, mean, and max temperature value per weather station and emits the results on standard out. So this is something we haven't done. Rounded to one fractional digit. So this is something we haven't really done. So we should probably create a function for this, like void report results, and it takes in the record maps, record star record maps, and I think we can, so join record maps. We could use join record maps and report results, join record maps, and report, and report, and report. Okay, join record maps and report. So here in the end we want to report the record, which let's just do this simple, like with f open obrc. We are currently reporting into a CSV file, which is probably not the way we should have done it in the first place. So let's just, oh no, we want to report to standard out, and then we print this open brace, and then we print, we probably don't want to do it this way, but we can optimize it later. It's probably not that much of an issue, not that big of an issue. So print fprintf standard out. Again, the chat is gone. We want to print the name dot star as then an equal sign, and then the temperature, so %.1f. I don't know if that's compliant with the solution, but let's just use the standard format string for now. And then we want to fprintf standard out, and we want to print the final closing brace with a new line. So no new line here, but a comma, and probably no comma in the end, but I mean, it doesn't really matter. Yeah, we only want to print this if this is actually present. So we want to do record city name dot length, record city name dot pointer, struct string dot pointer, and then we want to report the min, mean, and max. Let's see, base. Yeah. So record min temp, record mean temp is equal to or over equals f64 record count, and record mean temp, record max temp. All right, so this is 3 values, %1f, %1f, with a comma. No, it's a slash. record. What? Percent and this should be an I32. Oh, this is an I16. So let's convert them. Min temp is equal record min temp as an F64 divided by 10 or even 0.1 times max temp mean temp over F64 record count. Then we print it. So now we say here min temp, mean temp, max temp, build. And let's also run it. And as you can see, we get a result, which may or may not be correct. Let's search for, can we like, okay, this is a little bit unfortunate. Or maybe pipe this into less, I don't know. Okay, and search for Berlin. Can we search for something? No. 1BRC out. Berlin. There we go. Okay. So now we also spend some time in join record maps and report. As you can see, it's just 0.44 milliseconds, so it may or may not be important to us. Now it would be nice to see the assembly output for our find character loop. Maybe we can get it. So let's see. So while array, let's just see if we can see this. I don't know. So now we are here. Let's open the disassembly view. And as you can see, we do an underlined move. We do two comparisons. We OR them together like so, and we do one pmove mask. So this is probably how we should have done it also. Move mask. Because it doesn't make sense to do these two. We can just directly OR them together. Let's say fused mask is equal to mm256, and I think let's just enable this mm256 or SI256 or SI256 and new line mask semicolon mask, and then we can do a fused bit mask. Fused bit mask is equal to mm256 move mask EPI 8 of the fused mask. Then we don't need this, we don't need this, we just do fused bit mask. We do fused bit mask, fused bit mask, fused bit mask. All right, so obviously this doesn't change the code, but if we were to fuse, I mean, shouldn't change the code, right? Seems correct. Let's just print Berlin. Fprint f. Let's say if obrc brc debug. We only do this print out if the city name is like string equal record city name to string Berlin. And otherwise we do the printf every time, so that we don't just have the entire output here, and we can quickly check whether this is the same. So now we don't get anything. Why don't we get ooh, this is wrong. -1. Yeah, now we get only Berlin in here. All right. And as you can see, if we now do this in debug mode, we were at, oh yeah, so find character wide is pretty slow in debug mode. So the compiler is doing some heavy optimizations, probably somehow. I don't know. Let's see what it does to our code. We have the pmoves mask, we have a test, a pop count. So what all of this we had in there, we have like okay, this LEA, the TZ count, add, move, inc, BLSR, compare, jump, TZ count. So it did unroll this loop. That's actually interesting. It did unroll it 4 times. I don't know why, but this may also be something we want to do in our code. Yeah. All right. So one thing I also want to collect is how many matches we get for each 32-byte for each 32-byte comparison, like find character metric, or how do we call this? Matches per compare. Like, is that something? Maybe. Find character wide. All right. So this already provides a massive speed up. But here we want to just say, okay, we also report the line. We should also report in debug info the compare count So find character wide. Here we want to say, okay, so if OBRC debug is defined, we want to say debug info dot compare count plus plus and debug info dot character, what was the name? My goodness, I forgot. Matches per compare. Matches per compare plus equals match count and if. And then when we print our debug info, like OBRC debug, where do we print it? Like here, we don't want to put it into a CSV. That we just don't do. We don't get the mean. We just do join record maps and report. But we want to print this debug info, so let's also say, okay, compare metrics, and then we get the, or average match count, or a mean match count, and then a tab, and this is the F64 mean match count is equal to debug info dot matches match per compare. I always forget matches per compare over the debug info dot compare count. Okay, so this is just the mean match count. So we also get a mean match count of, why is this not working? A mean match count of 4.6. So on average we get 4.6 matches. So either 4 or 5 probably. So one thing we can do is we can just unroll this loop 5 times, because on average we are getting 5 matches. How do we do this? We just do so while the fused bit mask is still set. We do this, the tz count extract, tz count extract fused tz count extract, tz count extract, and we just do it 5 times. And then we correct, like not do this. Oh well, we should. Yeah, this is at array length. This is at array length plus 1. This is at array length plus 2. Array length plus 3. Array length plus 4. And this now array length is going to be incremented by the match count. Now we don't need this anymore. So this is our now unlooped loop. Unrolled loop, yeah. And now it's segmentation faults. Okay, where does it segmentation fault? Let's go into the build again. Let's do the debug build and let's see if it also segmentation faults. It does. So let's go here. Let's just remove all breakpoints and run it. Continue. Boom. Seg fault. This is weird. Okay, LLDB 1BRC run. Address not mapped to object. So this is very, very weird. If we do not unloop this, unroll this, like let's say, okay, if 0 and if, and let's keep the no else, let's keep the other version as well, while fused bit mask and u32 index is equal to mmtz count 32 fused bit mask, and then index array at array length plus plus is equal to index plus offset, and fused bit mask is equal to blsr u32 fused bit mask Okay, unrolling the loop has somehow implications on something else. So maybe we shouldn't, maybe this is causing problems here. Let's just do it 2 times. So if 1. No, it's still segmentation faults. I wonder where though. Why does unrolling this loop causes a segmentation fault? Let's set it to 0 again. And this is very, very weird. Index was offset, index was offset. Like, did we set index? We unrolled it. I'm confused. Like, maybe put this onto the arena. I don't know. Context alloc and then u64 and 2 times size of mm256i. Like, let's just not have it on the stack. It's still segmentation faults. I wonder why it does that. And why it does it in XX hash. So if the hash function let's just say, okay, digest Like we're not even calling XXH32. Where does it now segmentation fault? Now it does it in here, which is weird. Like, why does unrolling this loop cause this problem? Like, what if we have no matches? Like, 0 should be just 0. Yeah, we should go into the debugger and see what happens actually. So let's see. White. Here, let's go. All right. Go here. TZ count. We should be correcting. Like, what is this? What is it? Why are you complaining? Okay, index is 6. Index is 11. Index 32. 31. Fused bit mask is 0. Array length is 5. Now it should consume these. Okay, that works. It should also consume the next, which also works. So match count is 5. Fused bit mask. Let's just see what happens. This is still correct. Still works. Now array length is 0. Match count is 4. So now we are setting so now it is 0. Index TZ count is 32. Index array. Like, where does it fail? Where does it fail? I don't know. Like, can we just like what are the values here? What happened? What happened? Why does unrolling it make it bad? Shit. So new line index 60, semicolon index 128. Like, they're not correct. They're pointing to A. So I don't know. Cursor plus offset. And why does unrolling the loop causes this weird behavior? I'm deeply confused. Like, what is the line count? Debug info dot line count. Debug info dot line count is 9. So we're hitting it on line 9. The hash function is obviously not the problem. Hash. Let's keep this. The problem is probably which, like, city length. Why is it 4 million, or like city length is semicolon index minus line start? Index plus offset, index plus offset. Like, what is line start? 129. And semicolon index is 128. What? Are we doing something completely stupid? Are we doing something completely stupid? Like, why is it 129 and the semicolon index is 128 and the new line index is even 60? Like, what happens in line 9? Let's stop this. Let's go here again and run. So we are currently in line, I don't know. So we have an index array. I don't know where it is, but it's here. Shit. So now can we like view this? Like U32, 32, index array, UN32T. Come on. these indices? Index array, it's just bogus values. Look at this. Huh? Hello, index array. Why aren't you updating? Stop. Oh no, it's not U32, it's U64. May that be the problem? Also, we have an I64 here. It's a U64. It's a U64. It's a U64. Okay. Continue. Go in here. Index arrays now does have something. All right. So this works. But index array, it seems to contain bogus values. Hey, index array, what are you doing? Is it still that is it that it doesn't update in here? I don't know. Like index array, where is it? Here. It has a 6, so why is it not why does it not say 6 here? I don't know. 6. Index array. At 10. Okay. So I don't know for what reason. So we have these values in here. Now we extract them and get the correct thing. Now what is happening? We reset and then we go ahead and do the load, do all of this, get the match count, which is 5 again. Index is, I don't know what index is. It said index is 3. That's fine. Now we get good values. We put it in there. That's okay. We get a bit mask. We put this in these indices in here. Right. So now we see 86, 91. Okay, that's okay. Like why don't we have these? Okay. So now match count is 6. So this may be the problem. Okay, we get an index of 2. 98. A new line, 103, 110, 115. And this is where the bug is. I see where the bug is. We have to pull this array length plus equals match count Now this doesn't work. Let's say U32 current length, array length. Then we do array length, no, current length plus 1. Or current length plus plus. Current length plus plus. Or even something else like index pointer is equal to index array. And then we do star index pointer plus plus star index pointer plus plus star index pointer plus plus. Then we don't need this current length. Star index pointer plus plus and star index pointer. Ah, shit. Plus plus. Now, then we correct for the actual match count, and I think it should work then. Assertion not. What the heck? Are we now seeing ghosts? How can that happen? Assertion not full. What? Alright, so I guess we have to debug it again. Dang. Is this so hard to get it right? Like, I don't think so. Like, this works. Array length plus equals this. It seems correct. Why is this incorrect? Oh no. Oh no. Index array plus array length. We have to be at the current one. At the current index. Ah. That's quite some bug, but now it works. Okay. So now So now we did just what the compiler did for us. Unroll it. And I don't think so. Maybe this doesn't even do anything. But it's a nice kind of gimmick to have. Like, let's see. As we can see, it's actually faster. Like if we set it like so and build it, it's slower this way. Like, the unrolled version is actually faster. Yep. So that's also nice to know. Maybe if we go now here and set a breakpoint here and continue and show the disassembly, we can now see that we have 1 TZ count, 2, 3, 4, and 5. So 5 instead of 4 times the unrolling. Because we collected this metric that we have on average 4.6 matches, we could do this unrolling here. Like, let's say on average on the small test set we have 4.6 matches per 32-byte comparison. Therefore, we unroll the loop 5 times. All right. So one thing I want to do is maybe do this, like do 2 of these instead of just 1. I'm pretty sure it also just does 1 load, 2 comparisons, an OR, a move mask. What if we just do it twice? So what if we just say, okay, we do a second bytes reg at offset plus size of 256i. So this is the second load. Then we also get like, let's just do it like this. Fused mask. Like, yeah. Just do this again. Like, pull this into a 64-bit register. Because our mask was in 32-bit, in a 32-bit register. We can do this twice, but we have to add the size of the 256i register, which is 32. Then we do another one of these. Fuse mask is now this. And now we do the upper. So this should be the upper mask. Let's say this is the lower mask. And lower mask 32, upper mask 32, U64, MM256, move mask, EPI 8, fused mask. And now we want to say fused, not fused mask, but, oh yeah, fused mask, okay. Fused bit mask is equal to the upper mask 32 shifted left by 32, or together with the lower mask 32. Now we can delete this. We can use the fused bit mask, and let's see what it does, if it even does anything. Where did we do that? Did you mean MM256 move mask EPI 8? Oh yeah, move mask. Let's just see what that does. So this increases, but let's just unloop this. As you can see, no. Oh. So this should now be 2. And also this up here should be 2 times. Oh no, okay, so it's still broken. Match, oh, pop count U32, pop count U32, pop count, so other, pop count U64 we have to use. Okay, now we get a segmentation fault. Okay, let's see. Bytes reg. We load it into bytes reg. Semicolon mask. We do the new line. We do the fused mask by ORing them together. We move mask. Then we fuse them together. I don't see anything wrong with this. And then we move the offset by 2. I don't see anything wrong with this. So why does it build? Where does it segmentation fault? We see it in mem equal again, which tells us that something went wrong beforehand already. I think this should be correct. Like this should be correct. Oh, so let's now do 4. I don't know if that is any. That may be causing problems, but theoretically it shouldn't. Yeah, it doesn't. So do the first load, do the compare, do the compare, do the OR, do the move mask, do the second load. I don't really get it. Now match count, compare count. Maybe this is a U64. It is. So this is this shouldn't really be a problem. Nope, it's not. We want to get the pop count U64. Pop count U64. What's wrong with this? What is wrong with this? Move mask. PPI 8. just add these. This shouldn't do anything. Plus, maybe this is wrong. Should look at the debugger. Fused bit mask. Fused bit mask. Upper mask 32. Lower mask 32. Like, do we have to, does it have to be the other way around? No, it doesn't. Like, new line, reg, semi-reg. Okay, so what's going on? What is going on? Okay. Where's the call stack? Here, entry point. Okay. So, yeah, it's clearly wrong. What debug info line count is 4. Okay. Okay, let's see. Let's just break here. Let's run it. Oh, we do tz count 32. Oh my goodness, tz count 32. We have to do it in 64-bit. Tz count. Oh man, 32, 64. Oh. Tz count. S32, 64, global. BLSR, U64. Yeah, so we were doing it on 32-bit. And now it's spinning. Now it seems to be a spinning loop. Where is it spinning? Come on. I thought we were setting tz count U64. Let's just use U64. Like tz count U64. Okay, it's still spinning. So pop count. Bytes reg, semicolon reg, bytes reg, new line mask, semicolon mask. Fused mask 2. We OR them together. Okay, I don't know what's happening. So let's go into the debugger. Let's continue. There we go. Let's see. Lower mask. Ooh, this is a big value. Oof. Okay. Why is it so large? Like this is way over. Move mask EPI 8. Like this is way over the top. Let's say this is 32. No, U32, U64. Let's just say we cast this to a U64. Like if this is the problem, I don't know, man. This was apparently the problem. Okay. So the top bits were set of this mask. This is no good. So this is a pretty damn pitfall. Hey, how are you doing? This is a pretty bad pitfall. Like move masks seem to not clear the top bits, and therefore we had a very large number in lower mask 32, which caused when we ORed them together to get an invalid result. That's pretty crazy actually. So let's see, in build, let's now execute this with O3 again. And as you can see, we now get 9.727 matches. And by doing it this way, we can even get the time and find character down by like 10 milliseconds in the simple case. So, but we know that on average we get 9.2 matches. So let's just unroll this loop a bunch of times again. So 1, 2, 3, 4, 5, 6, 7, 8, 9. This is pretty ugly, I know. And running it again gives us a worse time. So how many times do we unroll it? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times. And it's worse. So if we delete it a bunch of times, 1, 2, 3, 4, 5. And it's 10 milliseconds faster. I have no idea. Like, Who knows? Maybe let's look at the disassembly of this. Like now we can, let's see. So here, let's open disassembly. So here we're doing the we're doing two moves. A comparison. Here the last comparison. Order them together, 2p move mask, then we shift left, then we order them together, then we test whether there's 0. If there's 0, we jump. It's probably not 0. Then we unloop it 1, 2, 3, 4, 5 times. And we're good to go. Okay. Why can you please go like what is this? Hola, señorita. No hablas español. What are you doing? 1 billion road challenge. In C, currently using intrinsics and trying to do the trying to find the characters using AVX2 instructions. And we got our time down from 200 milliseconds and find character wide to 34 milliseconds. One thing I also want to do, so let's just for now say git status, git add dot 64 byte comparisons at a time. And is there a way to quickly say how many times we want to unroll this loop? I don't know. Let's just find out if we find a better sweet spot. Like this is 39. If we remove this, $35. So 5 seems to be a sweet spot. Actually, I have no idea why. We got 34. What if we remove even one further? So then it gets worse again. This is interesting. I wonder why that is, so. So, all right. Parse temperature I16. I want to take a look at that again because I think we can do better in there as well. So parse temperature I16 looks at individual bytes. I think we can do better by loading this into a 64-bit register. So temp stir 64 is equal to u64 star stir and dereference the pointer. Now we want to check now the sign is equal to something else. It is equal to temp 60 stir 64 shifted to the right by, so the minus sign is at the very top. If it is there, shift by 56. And if this is equal to the minus sign, I mean, we could also do it a little bit differently. We could say, we could mask it out or something like this. let's just keep it like this. So if we have a sign, let's just say temp stir 64. Is there a sign? If yes, we shift the temp stir down by 8. No, we shift it left by 8. And else we just keep it. Then what we do is we just parse it so we can either have 3 digits, so we can either have this format 9.9 or we can have 99.9. What we can do is we basically compute both results and then do a conditional move at the end. So let's say U32 2 digits is equal to temp stir 64. Now we should select the we have to select the second byte, which, so we have to shift right by 48. And if that is equal to the dot, then we have 2 digits. Now let's say U8 D0 is equal to temp stir 64. Shift right 56. And it together. Hi mister, how are you doing? 0x 0f. Digit 1 is equal to shift right by 48. Or maybe we do it differently and say temp stir 64 and equals 0x 0f. I'm doing great. 0f. So that's 2, 3, 4, 2, 3, no, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So this basically, well, I just lay down on the sofa to rest a little, and in a little while I'll start continuing with the Rust project. Nice. What are you working on? So this is digit 0. This is digit 1. And this is digit 2. So the dot is either Q8D3, temp stir is 64, shifted to the right by 36. I mean, we could say we shifted completely. I'm working on a personal challenge, learning Rust, and I'm orienting him to the math. I'm using a plotter to calculate and print parabolas. Nice, sounds cool. Okay. So result I16, result 1. Oh, let's just say this is I. No, U is equal to digit 0. So this is the 2-digit result, is D0, which is the 9. times 10 plus D2. And 3-digit result is equal to, let's look at this, 100 times D0 plus 10 times D1 plus D3. And then we say, so I64 result is equal to, so if we have 2 digits, we get the 2-digit result, and otherwise we get the 3-digit result. How's your story? We are actually, we made some progress, and we got the wide character, the wide character identification working, which significantly, like, this was kind of an almost 7x speed up doing it with AVX2, which is quite nice. But I now want to also change this function. And let's see, past temperature I16 is not faster. It's not a single bit faster. Okay. It's actually a little bit slower, right? I don't know. Maybe we can get this to, I mean, we can say temp stir 64. We should shift it down. I mean, if it's only 4 digits, and it can be at max 5. So this is 64 minus 5. Oh, also the results are now wrong. So it's not correct what we did here. We have to check that. So temp stir shift down by shift down. So this is in the 5th position. So 1, 2, 3, 4. Shift it down by 4. No. This is not correct. This is 8 bits. So this solution was not correct, apparently, because yeah, it has a bug. I think we leave it at that for now. We broke the parse temperature function. I have to go now, and I will continue this. Like 36, this is ridiculous. 36, this is not correct. This should be 32. This may already be the bug. Nope, it wasn't the bug. Like 48, this and this, 110, D0, D1, D3, D0, D2. If the top like sign shift it to the right by 8, two digits, Is this shifted to the right by 48? To the right by 48, and it's together with 0xff. Still not correct. Oh yeah. We have to select the bottom bit here. 0xff. 0xff. 0x. I mean, we can then at this point we can just do this. Like, don't do this and just do this. Get the bottom 4 bits. It's still not correct. Ah, shit. Two digits. Let's see. Let's fix this one. Build it in debug. Okay, that's fine. And go into parse temperature I16. Just break here and run. So let's look at temp. Temp stir 64. Stir is this. Okay, temp stir. This should not have a sign. And 2 digits. It should be 3 digits. So 2 digits is also 0. P0 is 9. Why is D0 9? Oh, it's... Oh my god, I messed up the endianness. I messed this up completely. We should not have all these shifts here. They are in the bottom. Like 0xff. No, 0x and 0xff is equal to this. So if the bottom, then we shift it to the right by 8. 2 digits. So if we shift this down by 8, no. If we shift this down by 8 and get the bottom bit, is it a dot? This is the bottom 8 bits. This is the bottom. This is this 16 and 24. There we go. Now it's correct again. Let's compile it one more time with 03 and let's get the metrics. There we go. 99 milliseconds. Yeah, we'd have to look at the assembly and see whether it's actually different. Changed parse temperature with 64-bit load. It didn't really make a difference, to be honest. Okay, yeah, so let's leave it at that. We have made some nice progress with wide comparisons, and yeah, let's maybe do a final run with the big file and also lane count. Let's put this also into the build, like -d lane count is equal to 4. Build like 1brc.c. So if ndef lane count, then we define lane count as 1. So this way we can quickly switch. Let's call this see if it's working. Doesn't seem like it's working. Okay. It seems to be stuck. So it doesn't work. What if I do 1? Is this a multi-threading problem? Okay, so we have a bug. I feel. On the big file it doesn't work. So if I do -d obrc small, oh no, on the big file it takes 46 seconds. What? Profile function or begin. Takes 46 seconds. Let's try and increase the lane count. Top. And where is it? Oh, there we go. What? Why exactly did it do this? Did it just not really execute? Okay, so now we see it takes 7 seconds on the final, or 6.8. If we increase this to 8, say, we get 4.7 seconds. 6. Like that's already pretty good, like 4.9 seconds. We can live with that already. Yeah, so let's leave it at that. I